This is part 2 of lesson 3. We have 2 last class examples to get through, and then we will be done this lesson. Okay, so what it says is, let's have a look. The point P, which is negative 15, 8, lies on the terminal arm of a rotation angle in standard position. So what we always do is we always want to find where that point is. So that's the x coordinate and the y coordinate. So x is negative 15. So I'm going to put that here. So this is negative 15. And my y coordinate is at 8, right? So that point there would be negative 15, 8. The first thing that it says is mark the angle on the diagram as theta. So we know that our initial arm is always on the x-axis. It opens. This is where it terminates, and that would be theta. Okay. Next, it says calculate the exact length of OP, which is the radius. So OP is the O goes from the origin to the point, and this you have to just realize this is going to be, eventually what we're going to do is we're going to be making a circle, right? This is going to be like a unit circle, and that will always be the radius of our circle. Okay. So OP is the radius. Now we essentially have a triangle right here. So this is our triangle. And the length of this side is negative 15 units. It doesn't matter. We're going to square this. And the length of this is 8 units. So calculate the exact length of the radius. This is a 90-degree right angle triangle. So instead of c squared equals a squared plus b squared, we're going to use r squared equals x squared plus y squared. Okay, r squared is equal to. So again, we can't have a negative length, but it doesn't matter because when I square that, it will become positive. So negative 15 squared plus y squared, y is 8. R squared is equal to negative 15 squared plus 8 squared is 289. And to isolate r, you would square root both sides. So we would square root this, and we would square root this. The radius is equal to, now normally when you square root both sides, the square root principle says that the answer is positive or negative 13. But we would erase the negative because, again, we can't have a negative length, right? This length truly is 15. This length truly is 8. So when I go over to the radius is going to be 13 units. Sorry, not 13, 17. 289 square rooted is 17. 17 times 17 is 289, yes. Okay, so that's what r is equal to. Then it says, okay, using x is equal to negative 15, so that was our x, y is equal to 8, and r, so we've just calculated r is equal to 17. Determine the exact values of the primary and reciprocal trig ratios for angle theta. So here's how you would do this. I always start with sine, and I say, okay, the sine of theta, sine I always remember is 7 yellow rabbits, so it's y over r. So the exact value of the sine trig ratio would be y over r, which is 8 over 17. And that is the answer for the sine of theta. Then we'll do the cosine of theta. So if sine is 7 yellow rabbits, cosine of theta is x over r, which is equal to negative 15 over 17. The last primary trig ratio is the tan of theta. Tan you just have to memorize as y over x. And y over x would be 8 over negative 15. If I was to quickly just draw according to my cast rule, let's see if this makes sense. We were in quadrant 2, or we are in quadrant 2. only sine and the reciprocal of sine is positive. So if you look, sine's positive, these two are negative as they should be. Okay, so then let's do the reciprocal trig ratios. So those are the three primary. The reciprocal of sine is not secant, right? It's cosecant. Is the reciprocal of sine. If sine is y over r, cosecant is r over y, which is the reciprocal of this, and that would be 17 over 8. Cos theta, the reciprocal of cos is secant theta. Secant is r over x, which is going to be 17 over negative 15. The last reciprocal trig ratio is the reciprocal of tan, which is cotan. If tan is y over x, cotan is x over y, which would be negative 15 over 8. So there's your answer for class example number 5. Okay, let's do class example number 6, and then we'll do one from the homework. So class example number 6. We did some of these in 20-1, except of course we didn't have reciprocal trig ratios. So here's how we're going to do this. They give me the cotan of angle A, so this is just like the cotan of theta is equal to root 5 over 2. So what they want you to notice is that this ratio is at positive or negative, and root 5 over 2 is positive. So what I would do right away is I would say, okay, according to CAST, let's check off the quadrants where cotan is positive. So cotan is positive in this quadrant because tan and cotan are positive there, and in quadrant 1, right? So my answer right now could be in quadrant 1 or quadrant 3. But then they're going to actually tell us which of these two quadrants they want because they give us this. Between these two quadrants, please choose the one where sine A is negative. It could not be here because sine is positive there. So between the two quadrants, this quadrant here is where cotan is positive and sine is also negative. So my answer, or all my work, is going to be in quadrant 3, is what you need to realize. Okay, so let's draw a terminal arm in quadrant 3. The next thing we're going to do is we're going to say cotan. Now, cotan is the reciprocal of tan, right? So I don't have the reciprocal trig ratios memorized. I only have the primary trig ratios memorized. So I know that the tan of theta, in this case they don't want me to use theta, they want me to use A. The tan of A is y over x. That's what tan is. So cotan of A is the reciprocal of this, which would be x over y. So root 5 is my x and 2 is my y. Okay, so we know that our answers in this quadrant here, if x is root 5, so this is going to be root 5, and my y is 2. Now you might say, okay, wait a second, Mrs. King, isn't x negative in this direction? And you're right, x is negative in that direction, and y is also negative in this direction. But watch what happens. If we know that the cotan of A is equal to x over y, that is now, we just said x is negative root 5, and we said y is negative root 2. If you have negative root 5 over negative root 2, two negatives just give you a positive, right? So I could actually just erase those negatives. So you need to be able to, one, find which quadrant we're in, and we're in quadrant 3, and that was based on these two pieces of information. I narrow it down and I know I'm in quadrant 3. Then I need to find what side over what side. So I say, okay, cotan is reciprocal to tan. Tan is y over x, so this guy must be x over y. Okay? And then I label it. Here's my x's. X is negative, so I've got to put that in. Here's my y's. On your terminal arm, you always draw a point on your terminal arm and go up to your x-axis because you always want a right angle acute triangle, right? And then this is always going to be my radius. So that's my x value. So I'm going to put x is equal to negative root 5. This negative 2 is my y value, and let's calculate what the radius is. So for C, it says use x squared plus y squared equals r squared to determine the value of r. Okay, so r squared equals x squared plus y squared. R squared is equal to, again, it doesn't matter if I put in the negatives because even though you might say, well, we can't have a negative length. Well, that's true, but as soon as you square it, we get rid of it, right? So x is negative root 5 squared plus y is negative 2 squared. R squared is equal to, the square root of 5 squared is just going to be 5, plus negative 2 squared is 4. R squared is equal to 9. And then remember, we have to square root both sides. So r is equal to, we're not going to use the square root principle and say plus or minus 3 because my radius must be a positive number. You will never have a negative radius. So the radius is equal to 3. So that guy is 3. Okay, so now what it wants, now that we know what x is, right? So x is equal to, what was x? Negative root 5. We know y is equal to negative 2. And r is equal to 3. We could find all 6 trig ratios if they want, right? So we could find like the sine of A. Sine of A is 7 yellow rabbits, and the sine of A would be y over r, which would be negative 2 over 3. Then, what's the reciprocal of the sine? Is it secant or cosecant? And the reciprocal of sine is cosecant of A is equal to r over y, which is equal to the reciprocal of this guy, 3 over negative 2. Okay, then let's find, actually the question doesn't even want all 6 trig ratios. It wants us to find cosecant, which we just found. So I'm going to box this guy in. So cosecant is negative 3 over 2, and it wants secant. So again, I don't memorize secant. I memorize the primary trig ratio, and I know that's cos. So I'll do it over here. The cos of angle A, if sine is 7 yellow rabbits, cos is x over r, which is equal to negative root 5 over 3. That's what the cos of A is. If I know what the cos of A is, I could get the secant of A. So the secant of A is r over x, which is equal to 3 over negative root 5. Sorry, this 3 should be positive. So let's erase that. And that guy's negative. So 3 over negative root 5. Now, one thing that's super important that I almost forgot about, just like you learned in Math 20-1, we have to do what's called rationalizing the denominator. So we never give our answer with a radical in the denominator. So we need to get rid of that root 5. And what I'm actually going to do, you guys, so we don't get confused with the negative, I'm going to erase this negative and just put it up with a 3, right? Because the answer has to be, it has to be a negative answer, but it doesn't matter where I put my negative. So now I'm going to rationalize this. So I'm going to multiply both numerator and denominator by root 5. And I would get negative 3 root 5 all over root 5 times root 5 is 5, and that is my answer. So we always have to rationalize a denominator if we have a radical in the denominator. So the secant of A is negative 3 root 5 over 5. Okay, let's talk about the homework, and then I'm going to do a homework question with you. So you've already done 1 to 3, 4, A to C. I want you to do 5 to 9, 12 and 15. I'm going to start 9 with you. And number 15 is sort of a challenge question. So if you get stuck on number 15, you could see how they do it in the teacher's resource. I'd look there first. And then from there, you could come and ask me. I like the idea of number 15 for a test, just so that everybody's good with that. Let's look at number 9 together. Okay, so number 9. Sort of like the one we just did. The cosine of A is a negative number, a negative ratio. So what I'm going to do is I'm going to go and I'm going to draw my cast rule, C-A-S-T, and they tell me that cos is negative. So draw your cast and check off which two quadrants cos is negative in. So cos is negative here and here. But my answer is only going to be one of those two quadrants. They have to give me some more information to narrow it down. Do they want the answer in quadrant 2 or do they want the answer in quadrant 3? What they do is they give you a domain restriction. And they say that the angle A is less than 3 pi over 2 but greater than pi. So what you have to do is you have to put where is pi on the unit circle and where is 3 pi over 2. So pi is right here. Oops. This is where pi is. 3 pi over 2, if you don't have that memorized right now, that is the same thing as 6 pi over 4. So 6 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. 3 pi over 2 is right here. So what they said is they said the answer is less than 3 pi over 2, which would be in this direction, but greater than pi. So that means they want my answer in quadrant 3. Okay? So they want the answer in quadrant 3. So what we're going to do is let's draw a terminal arm in quadrant 3. And remember that you always draw a point on your arm. And it goes up to your x-axis. We need to figure out what this is as a ratio. So negative 0.28 on your calculator. Negative 0.28, math 1 fraction. That is negative 7 over 25. So what I'm going to do is I'm going to rewrite this, and I'm going to say, okay, the cos of angle A is negative 7 over 25. And sine is 7 yellow rabbits, so cos is x over r. So we're in this quadrant here. So my x is 7, or we know it's going to be negative 7. And my radius is 25. So my radius is 25. What is my y value is what we're going to have to calculate. So what is the y value? And y better be negative, right? So we know that r squared is equal to x squared plus y squared. If we want y squared is equal to r squared minus x squared. Y squared is equal to 25 squared minus x is negative 7, and I'm going to square that. Oh, and this has to be squared. Y squared is equal to, so 25 squared minus negative 7 squared. What you should get is 576. So you'll double check that on your calculator. But if you do 25 squared minus negative 7 squared, you should get 576. We square root both sides of this, and y is equal to, so according to the square root principle, it could be plus or minus 24. However, we are in quadrant 3, and y must be negative. So this answer is not going to be positive 24. The answer is going to be negative 24. Y is negative 24. Okay, so what is this question asking for? So now I know what x is. If you want, I could put that in. So x is negative 7. 25 is my radius, and y is negative 24. So they want cosecant of A. What is the reciprocal of cosecant? It's the sine. So the sine of angle A is 7 yellow rabbits. The sine of angle A is y over r, which is negative 24 over 25. Okay. The cosecant is the reciprocal of this guy. So the cosecant of A is equal to the reciprocal of this, which is 25 over 24. And it doesn't matter where I put my negative. I could put my negative on either one. It just, this answer has to be negative. And that right there is your final answer.